Okay, so if you don't have any questions, I will move on to what we have done. So recall that we defined the general log function, which is log base a of x, and we defined log base a of x to be the inverse of the a to the x function. And log base a of x, a couldn't be 1, right? Remember that a was not allowed to be 1. And log base a of x is y if and only if a to the y is x, right? So in some sense, I'm pretty sure when you did these things in pre-calculus or some other algebra courses in high school, you were showed that, hey, log base a of x is y, and you sort of raise a to the right hand side to get x, right? You raise a to the right hand side to get x. And so log base a of x and a to the x, these are inverses, so they undo each other, they do the opposite of each other, in the sense that if log base a takes x to y, then a to the x function takes y back to x, right? And the cancellation properties for inverses can be written in the following way. Log base a of a to the x is x, and a to the log base a of x is x as well. One caveat here is that note that the base for the log and the base for the exponential would have to be the same. Meaning that I cannot apply the cancellation properties. For example. So this is a warning. If I have log base 2 of 3 to the x, this is not equal to x, right? So the cancellation property can be applied when the base for log and the base for the exponential are the same. I could have said this: if I have log base 2 of 2 to the x, then I could say this is x, right? Notice that, however, I could say this is equal to what? X times log base 2 of 3, whatever log of 3 is. Is everybody okay? Any questions on that? Remember that we had this number e, which is a very special number in the sense that ln of e is 1, right? And notice that ln of e is basically the log function with base e, right? Sorry, ln of x. Let me use ln of x. Ln of x is the same as log base e of x, okay? That's what the ln function comes down to. Okay? Is everybody clear? Ln of x is the same as log base e of x, and ln of e is 1. Now my question to you, what is a log base a of a? What is log base a of a? It's got to be 1, isn't it? By definition, right? So if log base a of a, let's say I don't know what that is. Let's denote that by the number x. That would imply that a to the x is a, and a to the x is a, implies that the exponent here, x, has to be 1. Okay? So log base a of a is 1. Okay? What is log base a of 1? 0. That has to be 0, because it means that log base a of 1 is some number that imply if and only if a to the that number is 1, and the only exponent for which a to the that is 1 is 0, right? So that number has to be 0. So that means that log base a of 1 is always 0, just like the ln function, right? Any questions, anybody? All these exponential logarithm functions, inverse trig functions, you have to know their domains, their range exactly, okay? You have to remember their domains and range, okay? You remember we had this the laws of the ln function, right? I gave you 3 laws for the ln function. Same way we had laws for the exponential function e to the x, and then I also gave you the laws for the general exponential function, right? So what were the rules for the general exponential function? Let me go back and make sure remember I gave you the laws of exponent here. A to the x plus y is a to the x, a to the y, a to the x minus y, and ab to the x is equal to a to the x, b to the x. I want you to add one more here, which is what is a to the x to the exponent y. That's the same as a to the xy. So this would be a new one. Please add that to the laws of exponents. I think I proved for you number 3. All the other ones can be proved in the same way. Okay? Everybody's okay? If you go over the derivations of all these laws yourself, it gives you a better understanding of how things are working here. You're not required to prove these things in the exams or quizzes, but it is a good idea to go over them yourself. Let's write down the laws of the general logarithm, okay? So laws of the general logarithm. Here I want to do, here let's let x comma y be, well, let me just say this, x comma y, they are both greater than 0, and a is greater than 0, but a is not equal to 1. Okay, and here let R be a rational number. Number 1, what is log base a of x? In fact, any logarithm base a can be expressed in terms of the natural log. How? It is simply ln of x divided by ln of a. Okay? ln of x over ln of a, that's basically the log base a. So do I really need log base a? It is convenient, it is nice to have log base others, but what we can see now is that if we have ln, we actually have all of them, because the other ones are basically ln of x over ln of a. Okay. 2. What is so that means if you understand ln function very well, you should understand all the other log functions, because again, log base a is just ln of x over ln of a. Okay. What is log base a of x y? It is log base a of x plus log base a of y. 3. What is log base a of x divided by y? This is log base a of x minus log base a of y. 4. What is 4? Log base a of x to the r is equal to r log base a x. Just like the two, number 2, 3, and 4 are exactly like what you had for the ln function, right? We only have number 1 where we are expressing log base a in terms of the natural log function. Is everybody clear on these laws? Do you understand the meaning of each statement? Everybody understands the meaning of each statement. Now look at number 1. Can someone tell me what's the derivative of log base x of a? What's the derivative of log base a of x? What's the derivative of that? Yeah.
1 over x minus 1 over a.
1 over x minus.
We just use the natural log to find it.
Ln of a is fixed. A is a fixed number here, right? So the denominator ln of a that you're seeing on the right side is a fixed number. So you shouldn't be taking the derivative of ln of a, because you got 1 over a, right? That's the derivative of ln of a, but what I'm saying is that ln of a is a fixed constant there. Yeah, 1 over x times ln of a, right? And can you tell me when, for what values of a is that positive and what values of a is that negative? Yeah, the derivative would be negative when a is between 0 and 1. It would be positive when a is larger than 1, because the ln of a is positive when a is bigger than 1. When a is between 0 and 1, ln of a would be negative. So in one case, the function would be decreasing. The other case, the function would be increasing. Right? Is everybody okay with what I just said? Okay, so let me write that down. So number 1 implies that if I take the derivative with respect to x, I could calculate the derivative of log base a as before when I calculated the derivative of any inverse. Okay, but what I'm going to do is use that number 1, which says that log base a of x, that's the same as ln of x over ln of a. And what is this is the, you should think of this as having ln of a like this times ln of x, right? This is what we have within the brackets, and ln of a is fixed. A is fixed. Ln of a is fixed. It's a constant. So when you take the derivative, you get 1 over ln of a multiplied with the derivative of ln of x is 1 over x. Okay, so that's how we are getting. So that means at the end what I got is the derivative with respect to x log base a of x is 1 over, usually we write it this way, 1 over x ln of a. Okay, and notice a couple of things here. This derivative would be always, remember what's the domain of log base a of x? Positive numbers only, right? So this thing here would be positive. This derivative is positive in the case a is when a is larger than 1. Okay, and this is for any x. This is for any x between 0 and infinity. Okay, and this derivative is always negative no matter what x is when a is between 0 and 1 for x in the domain of the log function. So my point is the derivative is always positive if you have a number a which is greater than 1, and it's negative in the other case, and which means that in one case it's increasing, the other case it's decreasing. Okay, in one case it's increasing, the other case it's decreasing. And I want to write down an exercise for you, and you should do it. What's the second derivative? What's the second derivative? Well, the second derivative would be what? The derivative of the derivative, right? And the derivative is what? X, 1 over x ln of a. And if you take the derivative here, what are you getting? 1 over ln of a will be there. It's a constant. 1 over ln of a is a constant. It's going to be there. What's the derivative of 1 over x? So this derivative would be negative 1 over x squared ln of a. You should make sure you understand how this derivative is correct. Okay. My question to you now: can you decide concavity out of this? Yeah. So when is this guy? When is log base a? When is log base a of x concave up and concave down? This is concave up and concave down. In which case is it concave up? In which case is it concave down? Anybody? When a is greater than 1, when a is between 0 and 1, it is concave up, because in that case ln of a is negative. So you have negative 1 divided by ln of a, which is negative. They cancel out and you get something positive. So this derivative, note that this derivative this derivative is positive if a is here, and it's negative if a is larger than 1. So when a is larger than 1, it's going to be concave down, which makes sense. Remember, ln function is log base e, right? Well, e is bigger than 1. When e is bigger than 1, then it should be concave down. And if you remember the graph of ln, it's concave down. So this agrees with what I had for the ln function. Again, ln function is now ln base log base e. It's the same. Is everybody okay? Okay, now the exercise that I was talking about is the following. Is sketch the graph of log base 2 of x and log base half of x. Okay, I'll let you sketch them. You know how the function is when the function is should be increased. So the first one should be what? The first one should be increasing. The second one should be decreasing from what we decided. The first one should be concave down. The second one should be concave up, right? What else do I need to come up with the graph? I need to know what's happening at 0. I need to know what's happening at infinity. Right? I need to know what's happening at 0. I need to know what's happening at infinity. And I'll let you figure that out. That's your exercise. Come up with the graphs of these two functions. Any questions? Do you guys understand the question? Come up with the graphs of this. I will ask some of the graphing questions like this. Draw the graph of 2 to the x. Draw the graph of log base 1/3 of x and things like that. And you just have to know them. Okay. You won't have time to figure things out, how the graph works, okay? You just have to know what the graph is. Is everybody okay? Any questions on what we did so far? Now, I want to go back to the derivative formula that we got. We got this derivative formula right here. And another way of rewriting that formula would be what? Well, write it as an integral formula, right? So I can write the integral of 1 over x ln of a dx is log base a of x. Should you try to remember this? Well, okay, I mean, if you want to, but I think it's not a requirement that you remember this, and you probably shouldn't try to remember this because there are many other formulas that you have to. So you want to decrease the amount of formulas that you want to remember, and if you want to do that, then you don't have to remember this. Why? How would you find the integral of this integrand? If I ask you to find the integral of this integrand, and you don't know the formula, right, that I have in front of you, how would you do this? Well, 1 over ln of a is a constant, right? 1 over ln of a is a constant. You can take this 1 over ln of a outside of the integral, and then the integrand is just 1 over x. What's the integral of 1 over x? ln. So you get ln of x over ln of a, right? So my point is, if someone gives you an integral like 1 over x times ln of 5 or whatever, you know how to find the integral. You don't have to remember that formula. If you do, that's fine, but if you don't, you can still do it. Is everybody okay? All right. So now I want to, though, do an example where I am going to make use of that derivative formula. So let's say I have y to be at y as log base 10 of 2 plus sine x. Log base 10 of 2 plus sine x. How would I find the derivative? How would I find the derivative? Well, if I had log base 10 of x, right? If I had log base 10 of x, I know how to find the derivative. So imagine 2 plus sine x. Let's say our eyes are so bad that 2 plus sine x looks like x, okay? So if it looks like x, then I know that the derivative would be what? 1 over x times ln of 10. But then I know that now my eyes are better. 2 plus sine x isn't really x, so I have to multiply by what? Multiply by its derivative. What's the derivative of 2? 0. What's the derivative of sine? So I have to multiply by the derivative of 2 plus sine x, which is cosine x, and that's the derivative. Is that okay? Alright, I'm going to redo this problem in a little bit differently. Again, not to confuse you, but to show you also all the other valid ways. This is how I'm not going to remember the formula. So I have a memory loss. I don't remember the derivative formula for log base 10. So, but you always have to remember one thing. Log base 10, 2 plus sine x. It is okay to forget the derivative formula, okay? But the most important theorem that you need to remember is that, remember this first law. The first law says log base a of x is ln of x over ln of a. You have to know that. Okay, this is a very important fact to know, but it is less important to remember the derivative formula, because I can just rewrite my, anytime you have a log base 10, just express it in terms of ln. So this is ln of 2 plus sine x divided by ln of 10. Right? ln of that divided by ln of the base 10. And then you take the derivative. ln of 10 is just a fixed number. So what's the derivative? The derivative would be 1 over ln of 10. I'm going to keep that because it's a constant. And I need to take the derivative of ln. So again, let me write it down here. This is the same as 1 over ln of 10 times ln of 2 plus sine x. Whoops. 2 plus sine x. Right? So ln of 10 is just a constant, so the derivative would be this. 1 over ln of 10, and what's the derivative of ln of something? We know that. ln of something would be 1 over that something, 2 plus sine x. And then I have to multiply by the derivative of that something, which is cosine x. Okay, you get the same answer either way. But for me, you have to remember this conversion formula, that log base a can be written in terms of ln. This is very, very important to know. So if I remember that, why do I need to bother remembering the derivative also? I can just use that to find my derivative. That doesn't mean you do. I'm not saying that you don't. It's bad to remember that. I'm just saying that you don't have to remember that. But you have to know this conversion one. You have to know the conversion one. Okay? Is everybody okay with that example? I have done it two different ways. You can either remember the first one, but probably if you are in pharmacy, you'll probably rather remember the first one, right? But a lot of the engineers probably would like the other one. Either way, it's your choice, okay? I'm not saying it's bad to remember things. I'm not saying it's bad to memorize stuff, but there are so many formulas that you might want to be efficient and remember the ones that you have to, and then use them to sort of take care of the other ones. Any questions at all? Maybe I should do one more. Let's say I have y is log base 2 of 1 minus 3x. Well, right away, what I'm going to do, I'm going to rewrite this as ln of 1 minus 3x divided by ln of 2. Which means what I have is 1 over ln of 2 times ln of 1 minus 3x. So now, if I take the derivative, 1 over ln of 2 is fixed. And I take the derivative of ln of 1 minus 3x, which would be 1 over 1 minus 3x multiplied with negative 3. Are we okay with what I just said? Okay, now since this conversion formula, that converting log base a to ln is so important, I want to show you how easy it is to derive it. Okay, so this is proof of law number 1 that I gave you. Okay, what was that? I needed to show the log base a of x is ln x over ln a. Let's see how easy it is to derive it. What I'm going to do is that let y to be log base a of x. Remember, I want to show then y is equal to ln of x over ln of a. Well, how? Well, this implies what? Log base a is the inverse of a to the x. So that means if y is log base a of x, then what is x? I can say that a to the y is equal to x, right? A to the y would be equal to x, right? Because the exponential and the log base a, they are the inverses, right? In other words, you're raising the base a to y to get x, right? Everybody's cool? Well, now I'm going to apply ln on both sides. So what is ln of a to the y? Well, ln of a to the y, ln has this cool property, right? ln has this cool property that the exponent can be moved in front of the ln function, and then I get y to be ln of a. Y ln of a is ln of x, and then finally I can solve for y. So y is ln of x over ln of a, and remember what y is. Y is log base a of x. So the log base a of x is indeed ln of x over ln of a. Is that making sense? How do you prove the other ones? Very similarly, I won't bother. You can look up the text, or you should try to derive it yourself. If you can derive it yourself, it means that you really, really understand these things very well. Any questions so far? Any questions at all? I think one of the things that I forgot to tell you last time when we talked about a to the x function, right? Where did I talk about the derivative of a to the x? Okay, so here you see that the derivative of a to the x is a to the x ln of a, right? Another way of writing that fact would be that if I take the integral of a to the x, what would I get? If I take the integral of a to the x, what would I get? It will be 1 over ln of a times a to the x. Why? Well, you want to... This is the right hand side is the antiderivative of the a to the x function, right? So if you take the derivative of the right hand side, don't you get exactly a to the x? That's the integrand, right? So basically you have this constant here ln of a. You basically divide both sides by that constant, and that gives you the integral formula, right? Divide both sides by ln of a, then it's going to say that the derivative of 1 over ln of a to the x is equal to a to the x. So that's exactly the integration formula that I have. Is everybody okay? You guys realize that? The integral of a to the x would be 1 over ln of a times a to the x plus c. Okay, how do I derive that? Well, in this equation, divide both sides by ln of a. And remember, ln of a is constant. So divide both sides by ln of a. What the left-hand side will then become the derivative of 1 over ln of a times a to the x. The right-hand side becomes a to the x. Okay. And that does it to show that that's the derivative formula for that. So as an example, what's the integral of 5 to the x? Well, it is 1 over ln of 5 times 5 to the x. Is everybody okay with what I said? More examples. What is if I have log of 5 base 8, right? That can be written as, so maybe the question is write things in terms of the ln. So this would be ln of 5 over ln of 8. If I say, if I ask you, hey, what's the value of log base 5 of 125, what did you say? 3. Yeah, very good. So basically you're looking for a power of 5 which is going to give you 125, right? Power of 5 giving you 125. Or in other words, you can think of this as, try to write the number in terms of a power of 5, so you get 5 to the 3, right? That's 125. 5 times 5 times 5 is 125. So this is equal to 3 times log base 5 of 5. Log base 5 of 5 is 1, and you get 3. But again, you can just write down 3 because you see that log of 125 base 5 means you're looking for a exponent on 5 that's going to give you 125. The power of, what's the power of 5 that gives you 125? That's the at the end, that's the answer that comes out to be. More exercises. Let's say I have 10 to the power x squared. And the question is, express it in terms of the e to the x function. express it in terms of the e to the x function? Well, in terms of the e to the x function, what is it? Anybody? I want to write it as e to the power something. What is it? What's that? E to the? What is a to the x? A to the x is e to the x ln of a, right? Yep, x squared ln of 10. That's exactly what it means. What is x to the cosine x? Someone else. What is x to the cosine x in terms of e to the something? Anybody? What is x to the cosine x? Yeah. Very good. E to the cosine. Same exponent remains. You multiply by the ln of the base, right? E to the same exponent you have times the ln of the base, and that's how you can convert things to in terms of the e function. Okay. Okay, very quickly, what's the derivative of 2 to the 7x? What's that derivative? Anyone? Okay, if you don't remember the formula for 2 to the power x, right? What should you do? What should you do? 2 to the power 7x. If you don't remember the formula for the derivative of 2 to the x, what's the derivative of 2 to the x? Well, if you don't remember the formula, just write it down as e to the power what? 7x ln of 2, right? And what's the derivative? Derivative is the same thing. 7x ln of 2 multiplied by the derivative of the exponent. What is that? What's the derivative of the exponent? Don't tell me half is going to come up, okay? 7 times ln of 2, right? 7 times ln of 2, those two are like constants there, right? So x is multiplied with some constant there. So the derivative is 7 ln of 2. Don't say half is going to come up, okay? Half is not going to come up there. Okay. So now this quantity here is what? That is still 2 to the 7x, right? Times 7 ln of 2. Are we okay with that? Any questions, anyone at all? Any questions at all? No? Okay, the number e, so this is a very important example. The number e, I'm pretty sure you have seen this if you have seen calculus before, that if I take the limit of 1 plus x to the 1 over x, okay, and that's actually the same as if I take the limit as x goes to infinity of 1 plus 1 over x to the power x. Both of them are equal to e. Okay, so we can think of e as the limit of this this functions, either as x goes to 0 or x goes to infinity. I will let you figure out why are these two the same. It's very easy to see why they are the same. You just have to think for a second. But I'm going to show you why the limit x goes to 0 is equal to e. Okay. Is everybody okay? So let me show you in the next few minutes what's the limit as x goes to 0. 1 plus x to the 1 over x. Right? That's what I want to come up with. I'm going to rewrite this as the limit as x going to 0. I don't like the way the function is written, so I will feel more comfortable if I write the function in terms of e. So I'm going to write it as e to the 1 over x ln of 1 plus x. Right? I can express it in terms of e. Now it seems like all I have to do is come up with the limit of the exponent, right? So let's focus now on the limit as x goes to 0 of 1 over x times ln of x. If I know that limit, ln of 1 plus x. If I know this limit, then I can just put that on the exponent and I get my answer. Now remember what I want to show. I want to show that the limit is e, which means I want to show that the limit of the exponent is 1. So let's see if this is really 1. So this is equal to the limit as x goes to 0. I'm going to rewrite this as ln of 1 plus x divided by x. Okay? Now, would you agree that what I'm going to do now is that I'm going to realize something, okay? Maybe it's going to take a long time to realize, but at some point, hopefully, that I feel like it looks like the limit definition of the derivative of something, and I want to subtract something here, okay? Subtract ln of 1. Why can I subtract ln of 1? Well, it's just 0. Ln of 1 is just 0. So I'm subtracting 0, doesn't change anything. But now, notice how it looks like. Now I'm going to do one more step. Maybe the x there doesn't make it look like the derivative of something. Let's replace x by h. So I'm going to replace x by h. I get ln of 1 plus h minus ln of 1 over h. And if you think about it, if I take the function f of x, to be ln of x, this is just f prime of x. F prime of 1. This is f prime of 1. If you think about the limit definition of derivative, if I take f of x to be ln of x, f prime of 1 by definition is that limit. Okay? Well, do I know the derivative of ln of x? What is the derivative of ln of x? 1 over x. So this f prime of 1 is exactly 1. Right? Now I'm using the derivative, because I already know the derivative of ln, I'm using that to compute this limit. Am I making sense? So what's the limit that so what we got is that the limit as x goes to 0 of e to the what I had was e to the what was that? X times ln of 1 plus x, right? 1 over x. And what we found is that the limit of the exponent turns out to be 1, so I get e. Okay? I get e. This limit comes up in so many application areas that's the reason that I showed you this. For example, let me give you an application problem. Suppose that you have a savings account. You put down let's say you put down $1,000. The interest rate is 5%. The interest rate is 5%. It's a and at the end of T years, how much money will you have? Okay. You can look that up in the Google or something, but I'll try to say something about that next time. Okay. All right. You should put your quizzes on the table. What?
Is it right if I just do that?
Yeah, that's fine. But if you have the details, yeah.
Good.